Hello everyone, welcome back to my YouTube channel Chemistry Without Fear. Today we are going to understand two very important concepts from class 11 chemistry, chapter number 1, some basic concept of chemistry. First we will learn about scientific notation and then we will move to our 5 laws. Both concepts are very important for understanding the basics of chemistry. So, let's get started. Scientific notations. Scientific notation is a way of writing very large or a very small number in a simple form. In a chemistry, we often deal with very large numbers like 6.0000000000000, right? And very small number like 0.00000000000000166, right? Writing them normally is very difficult, so we use a scientific notations. Scientific notation is written in a form of a into 10 raised to n. Here a is number of between 1 and 10, right? And n is an integer like a positive or a negative. Okay, let's just take a large number. This is our large number. Okay, in the scientific notation this becomes is 6.022 into 10 raised to 23. Here 6.022 is between, this is between a and 10, 1 and 10. Okay, and 23 shows how many places the decimal moves. This number is very important in chemistry. It is called the Avogadro number. This is called the Avogadro number. Example for a small number. Now let us take a small number. This is our small number, right? This is our small number and this becomes a large number, right? In this becomes, what can I write, will be in a different color we shade, and we use a 1 point. Here we can write 1.66 into 10 raised to minus 24, right? Here the negative sign show that the decimal move to the right. It is used for very small value like the mass of an atom. Okay. Here are the important rules. First, the first number must be between 1 and 10. Second, count how many places the decimal moves. 1, here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23. Okay. If the decimal move to left, exponent is a positive. And if the decimal move to the right, here our decimal move to the left, so our exponent is positive. If decimal move to the right, the exponent is a negative. Okay, scientific notation make a calculation easier in a chemistry. Okay, here we can see decimal or a scientific notation. Some move decimal point right or a left to arrange a one digit to the left digit point. Here we can use more example. 52,314 move to left 4 places. We can write as a 5.2314 into 10 raised to 4, right? Here 3.2, no need to move, so we can use a 3.2 into 10 raised to 0. Here Move to right of 5 places, 4.28 into 10 raised to minus 5. And then next is move left 8 places, so 6.02 into 10 raised to 8. Okay, clear? Next, our addition and subtractions. First of all, we calculate accuracy and the precisions, right? Accuracy means how close a measured value is to the true value, and precision is how close a repeated measurement are to each other. Repeated. For example, if the value of 10 grams, if the value is 10 gram, right? So accurate value is 9.9 or a 10.1 or a 10.0. This is accurate, and precious but not accurate, it's 8.5 or 8.6 or 8.5. So these are precious and these are accurate. Okay, both are important in a scientific notations. Ready? Here we can move what are the significant figures. Significant figures are meaningful digit in a number. They show a precision of measurement. The rule is first all the non-zero digits are significant. For example, 1, 2, 3. So there are 3 significants. Here we can use 2.738. So there are significance is 4. Second is 0 between non-zero digits are significant. Here we can use a 209 or a 3.002. Here 209 have a 3 significant number and 3.002 have a 4 significant rules. Okay. If the measurement of number is less than 1, the zeros on the right of a decimal point and the left of the first non-zero digit are non-significant. Here we can use 0.00807. First to 3 underlined zeros are non-significant. And the number of significant figures is only 3. Okay? And the fourth one is the terminal or a trailing zero is a number of without decimal point are not significant. Just fold, we can write as a 12.3 or a 1230 centimeter or a 12300 mm has only 3 significant figures. Okay, and the fifth is the trailing zeros in a number with a decimal point are significant. This point we can use 3.800 kg as a 4 significant figures. And then last, a choice of a change of unit does not change the number of significant digit or figures in a measurement. Okay, here we can go for a rounding off. Rule number 1, if the digit to be dropped is less than 5, keep a previous digit same. We can use 2.5351, so we can use 2.54 because our previous digit are the same. Less than 3 is less than 5. And rule number 2, if the digit is more than 5, increase previous digit by 1. Here we can use 2.5350. So 5 is the same, so odd number. Round off we can use is a 2.54. Or even number, this is a 2, so we can write as a 2.52. It's the same. If the digit is more than 5, increase. Here we can go. If the more than 2, so we can write as a 4.34. So here 4 is the less than 5. So previous digit are same. This is 4.3 only. Okay. If we can digit, if the digit is more than 5, we can write as a 4.36. This is more than 5. So digit increase. Here increase 1. The answer is 4.4. Here answer is same. Okay. Rule number 3. If digit is exactly 5. If previous digit is even, keep a same. If digit is odd, increase by a 1. Okay. This avoids BS in a calculations. In addition, we can write as a, in addition and subtraction, result must be same number of a decimal place as the least precious number. For example, we can write as a 2.11 or 3.1. This is addition, right? So our answer is 5.21, right? Since 3.1 has only one decimal place, the answer is only, our answer is 5.2. This rule ensures proper accuracy. Ready? Any questions? Nothing? Okay, we can see here in this slide number, this one. Addition solution is this. Multiplication, this one, and the division also. We can use as the power of property. The property addition in subtraction, the power of 10 in each term must be equal to each other, right? In addition or subtraction. And multiplication, product of power is addition. Here 10 raised to 4 plus 10 raised to 2 is equal to 10 raised to 6. In a division, we can m minus n. So 10 raised to 7 and 10 raised to 4. 7 minus 4 is 3. So our answer is 10 raised to 3. You can remember in this law also. Okay. In this addition, when adding or subtracting, use the same number of decimal places in your final answer is measurement with a fewest decimal place. Least precious measurement. Using rounding rules to adjust the number of digits in the answer. You can see here 25.2, the 1 decimal place. And then next 1.34, this is 2 decimal places. Our answer is 26.54. Calculate that answer. And but 1 decimal place above. So our answer with only 1 decimal, this is 26.5. Okay. Next, law of combination. We can use this law in our 10th class, right? You can remember also. Let's get started. Law of conservation of mass, proposed by Anthony Lavoisier. It states mass can neither be created nor destroyed in a chemical reactions. Total mass of reactants equal to total mass of products. For example, 10 gram reactant react, product will be also weigh 10 gram. You can see here, law of conservation of mass state that matter can neither be created nor be destroyed in a chemical reaction. Here sulfur and Fe, sulfur has a 32 gram and iron has a 56 gram. Reactants both are same addition, and we can calculate our products is FeS is this is 88 gram. So this is a conservation of mass. Okay. Next, move to the law of definite proportions, proposed by Joseph Proust. It states a chemical compound always contains the same element in a same fixed proportion by mass. For example, water always contains hydrogen and oxygen in the mass ratio of 1:8, right? In a given compound always contain exactly same proportion of the element of, here you can use carbon monoxide. Carbon has a 3 gram and oxygen has a 4 gram. Total compound is a 7 gram carbon monoxide. Right? Oxygen to carbon mass ratio is 4:3. Okay, here we can carbon dioxide use 3 gram carbon and 8 gram oxygen. Total compound is 11 gram of carbon dioxide. Ratio of oxygen to carbon mass ratio is 8 is to 3 in a carbon dioxide, right? Our next comparing two mass of ratio. This is mass ratio of carbon dioxide and carbon monoxide. Carbon eliminated, and then we can see this 8 by 4. So our ratio is carbon dioxide and carbon monoxide is 2 is to 1. Okay, remember, understand. Let's to move. Law of multiple proportions proposed by John Dalton, right? It states when two elements from a more than one compound, the masses of one element that combine with fixed mass of the other are in a simple wall number ratios. For example, we can use is a carbon monoxide or carbon dioxide. For a fixed carbon oxygen mass ratio is 1 is to 2. Right? If two elements can combine to form a more than one compound, the masses of one element that combine with a fixed mass of the other element are in the simple wall number ratios. You can use this here. Nitrogen monoxide, mass of nitrogen is 14 and oxygen is 16. 14 is to 16. And nitrogen dioxide we can use 14 is to 32. So 16 and 32 is ratio of oxygen is 1 is to 2 also. Okay. Next, move to the next law. Law of Galilei-Sachs law of gaseous volume. When the gases combine or are a product in a chemical reaction, they do so in a simple ratio by a volume provided all the gases are at the same temperature and pressures. Repeated, it states gases combine in a simple wall number ratios by volume at a constant temperature and pressures. For example, volume of 2 volume of hydrogen, 1 volume of oxygen. So total number is 2 volume of water vapor. Okay, we can show here a chemical equilibrium with energy, carbon dioxide and water. It gives H2CO3. You can see here our arrows, energy and high reactants concentration drives reaction to produce more product and energy required also. And then next second step, chemical equilibrium, carbon dioxide and water, it gives H2CO3. But at the equilibrium, forward and reverse reactions are occurring at the same rate. No need to change in energy. And then next, third part, carbon dioxide and water gives H2CO3. High product concentration drives the reaction to produce more reactants. Energy released. Okay, understand? Here ratio you can see. Next, move to the next, Avogadro's law. It states equal volume of a gaseous at a same temperature and a pressure contain equal number of molecules. This explains why gases follow simple volume ratios. Okay, equal volume of gases contain equal number of molecules at a saturated or a standard temperature and a pressure. You can see here 2 mole of hydrogen or 1 mole of oxygen. We can combine each other and to give a 2 mole of water. Okay, this is Avogadro's rule. Next, move to the Dalton's atomic theory. Dalton proposed the first atomic theory in 1808. Postulates are matter is made up of atoms. Atoms are indivisible, or next the atom of same element are identical, or atom combine in a simple wall number ratios. And then fifth, atom are rearranged in reactions, etc. First is matter consists of indivisible atom. Okay. Second is all the atoms of a given element have identical properties, including identical mass also. Atoms of a different elements differ in a mass. And the third is compound are formed when an atom of a different elements combine in a fixed ratio. And then fourth one is the chemical reaction involve reorganization of atoms. These are neither created nor destroyed in a chemical reactions. Next, move to the limitations of Dalton's atomic theory. What is? First, Dalton said that atoms are indivisible, but atoms are divisible, right? For what? Atomic particle exists as a proton or a neutron or a electron, so it can be divisible. Second is we can find the isotopes is exist, so this rule is filled. And then third one is this rule could not explain a chemical bonding. Our chemical bonding theory is not defined by this rule. Still, Dalton theory formed the foundation of a modern chemistry. Okay? Today we covered scientific notations and accuracy and precision, significant figures, rounding rules, addition and subtraction rules, law of chemical combination, Dalton's atomic theory. This concept form the best of all chemistry. Okay, thank you for watching, and if you found this helpful, please like, share and subscribe and comment in below. Thank you.